PCMS Robotics students. This is Mr. Simpson. I'm coming to you today on Tuesday, April 21st. This is our 7th in our series of remote learning. I've been calling it distance learning, but I'm going to start referring to it as remote learning because it seems to be using more and more. Just recently, we've got the information that we're going to have more lessons than we had planned. We thought we were going to be coming back to school this next month, but it looks like we're not going to be coming back at all this school year. Today, we're going to get into a new lesson. I'm going to start out with the PowerPoint. And we have some past due assignments for weeks 1, 2, 3, and 4. The coronavirus video questions, those were already due. And there is currently a face mask assignment that's due this Friday. These are some that have already been turned in. I'm not saying these are the best or the worst. These just happen to be 3 pictures I had handy. And these are face masks that students came up with. So due this Friday's a face mask. Our weekly schedule, which we've kind of fallen into, which we're going to try to continue, is I'll be emailing updates on both Monday and Friday. Tuesday, we'll have a lesson, topic, and an assignment, and it'll be more academic based and not project based. Wednesdays every week will be the Zoom meeting time. That's 12 o'clock to 2, so if you have any questions or you need me to explain anything to you, that'd be a great time to stop by and say hi. Thursday, we'll be doing projects, trying to do projects that we can do at home with materials that most people would have available. And on Friday, as well as the email update, a lot of the assignments will be due on Fridays. So this week's topic is going to be how do fans work? And we're going to talk about the theory behind fans today. You'll have an assignment to work on at home on that. And then we'll get into a project based on fans on Thursday. When I think of fans, first off the bat, I think of like a desktop fan, like the one on the left, or one that sits on the floor, which is called a pedestal fan. These are the newer types of fans. These are called bladeless fans. They actually do have a blade, but the blade is in the base, and it runs at a very high rate of speed, and it forces the air out around the inside of these circles or oval shapes. Ceiling fans, you're real familiar with those. We have some of those at school, and a lot of you have them at home. Personal fans, I've seen students coming into school holding these in their hands. The one up here at the top right, you can clip onto anything. You can clip it onto your clothing, onto books at your desk. The one on the lower right, you would wear this one around your neck, and you could direct those fans to point at you wherever you would like. These are some things that we usually don't think of as fans. The bottom one is a computer fan for cooling off the components inside a computer case. This big one on the right, you'll find in automotive garages, in barns, in places where they need a high volume of air. It feels just like the breeze is blowing through a building. This one on the top left is called a squirrel cage blower or fan. You'll have these in your furnace, and most of you have these in your home in a furnace type device. And then fans don't have to be electric. They could be human powered. These down at the bottom left, I looked up funeral home fans. They used to hand these out in churches to keep people cool, and on the back would be an ad for a funeral home. This is one that you might have made yourself with a piece of notebook paper where you fold the paper back and forth. And the one at the top and the one on the right would be connected with Chinese and Asian cultures, and they're very ornate. And sometimes they're kind of expensive. So these are all examples of things I think of when I think of fans. Fans don't actually cool the air. They make you feel cooler through a couple ways. Your body gives off humidity or moisture, and it gathers around your skin. So it's almost like you have your own body atmosphere, and it sticks around you. And as that moisture is given off, it's very high humidity, which makes you feel warm. So by convection, this moisture comes out, and it just kind of forms an atmosphere around your body. The thing a fan can do is blow this away, and by reducing the moisture content around your body, you feel cooler. The other thing is evaporation. As you sweat, your skin becomes wet, or even if you just have water splashed on you. And then when wind comes by or breeze from a fan, it causes that to evaporate more rapidly, and it drops the temperature around you on your skin. This is an example of where they've taken a fan on the left, and they took a pencil and wrapped some paper around it, another pencil, wrapped some paper around it. The one farthest away, they heated up with hot water. The one on the left, they left the same. And then they blew a fan against both of those. They had temperature sensors on them, and the one on the left that was dry, the temperature didn't change at all. So just the air blowing against it didn't cause anything to happen. While the one on the right, it had hot water on it, but it cooled fairly rapidly. And when the fan was on, it would cool even faster, and it kept dropping much lower than the one on the left that was dry. So that was kind of an experiment to prove that evaporation causes cooling. In this example, it says fans do not cool the air. My wife always thinks by leaving the fan on her room that it's going to make it cooler, and that is not true at all. They do not cool the air. In this experiment, they put a cooler in a styrofoam cooler, and then they put a lid on it, and they left the fan running, and they measured the temperature, and it kept getting hotter on the inside. So it was hotter inside where the fan was running than on the outside. And that was because the motor here has a coil in it, the current's going through the coil, and the more current you have going through, the higher the temperature. So when that air's blowing, the air's coming in by the motor and it's coming out the fan, it's actually a little bit warmer than it would be if the air wasn't moving at all. And here's an infrared image. It says, here's a nice infrared image of a ceiling fan. You can clearly see the fan gets warm. So you can see the fan up here, the blades are going around and you can't see them, but you can see the heat giving off right around the motor and down below where it's blowing. So that's an example of that a motor in a fan does give off heat. When you look in your Google Classroom, you'll see how fans cool resources. There are going to be 3 resources in there, and then the worksheet you'll be doing for today is how do fans cool worksheet. Inside the resources, you'll have a Word document that you'll want to read. There's about 1 answer for each page that you read, and then there's 2 videos. And I think half the questions on the worksheet are from the 2 videos. The one video lasts about 4 minutes, the other one about 5 minutes, so it won't take a real long time, but pay attention. And as you're answering these questions, you're allowed to go back, or you can answer the questions as you're watching the video and reading the document. So you should be getting 100 on these, and I still have people getting below a 50. And I'm not sure if they're just guessing on the answers or if they're not taking the time to go back and look. But all the grades count, so make sure that you've got the correct answers. Between now and Thursday, start thinking about how you can make a fan, but don't make it. We're going to try to follow the engineering design process, which is what I wanted you to do on the face mask assignment, but I don't think hardly anybody did it. So we're going to be making a couple different fans, and that'll be Thursday, but don't start on it yet. Wait till the assignment comes out on Thursday. So until then, stay safe, and I will see you back here on Thursday. Just email me with any questions you might have about assignments. See you.